So 4.4 part 1. We're just going to do part 1 today. We'll do part 2 tomorrow. So it's a separate note. But 4.4 part 1 continues with our trig functions, kind of super similar to what we did before in 4.2 and 4.3. The only difference is before we were dealing with the unit circle, so our radius was 1. Now our radius can be any number. So sine of theta is going to be equal to y over r. Cosine theta is x over r. So if you think about it as like a triangle here, it's a little right triangle. Where you go on the x-axis is your x, where you go up and down, that's your y, and then your radius is here, so it makes a little triangle. So if I took the sine of theta here, it would be y over r, because it's opposite over hypotenuse. So it kind of just brings everything that we've learned together. Tangent is the same, y over x. Cotangent is the reciprocal of that, x over y. And then secant and cosecant are the reciprocals of the ones that they belong to. To find r, we use this formula, which is pretty much the same thing as Pythagorean theorem, because it's a right triangle, and r is our hypotenuse. So r is equal to the square root of x squared plus y squared. All right, example 1. Let -3, 4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. So -3 is going to be our x, 4 is our y, and then we can plug it into our formula to find r. So we know r is equal to the square root of x squared plus y squared. So r is going to be equal to the square root of -3 squared plus 4 squared. So r is equal to the square root of 9 plus 16. What's 9 plus 16? 25. And what's r equal to? 5. Your radius is always going to be positive here. So just positive 5. So our sine of theta, we know sine is y over r. So what would our sine of theta be? 4 over, what's our r? 4 over 5. Cosine of theta is x over r. So x is -3 over r is 5. It's -3 over 5. And then tangent of theta. Tangent is what over what? Y over x, so this would be 4 over -3. So it doesn't ask us for them, but we could find the reciprocal functions. So cosecant would be what? 5 over 4. Secant, 5 over -3. And cotangent, -3 over 4. So just the reciprocal of the ones that they pair with. All right, example 1. Well, I guess another example 1. Determine the exact values of the 6 trig functions of each angle theta. So what do I have to do first? Find r. So r is equal to the square root of x squared, so 4 squared, plus y squared. So 4 squared plus 3 squared. So r is equal to the square root of 16 plus 9. So r is equal to the square root of 25. What's the square root of 25? 5. Now I just have to find our 6 trig functions. So sine of theta is y over x. What's our y? 3. So it would be 3 over, it's y over r, sorry. So what's our r? 5. So 3 over 5. Cosine theta is x over r. What's our x? Bless you. So 4 over 5. And x over r. And tangent is y over r, so that would be 3 over y over x. Tangent's y over x. So 3 over 4.
So the tangent is the same one as the other one, right? Like from last chapter, it's y over x.
Yeah, because there's no r in it, so it's just y over x. So then we have cosecant. What would our cosecant be? 5 over 3. Secant, 5 over 4. And cotangent, 4 over 3. All right, let's look at B. What do I have to do first? Find r. So r is equal to the square root of x squared, so negative 8 squared plus 15 squared. What is negative 8 squared? 64. And what's 15 squared? 225. So 64 plus 225 is 289. Can I simplify the square root of 289?
Yes.
What is it?
17.
17. So r is always positive. It doesn't matter if your x and y are both negative, r is always going to be positive. What is negative 8 squared? It'll always be positive, so you'll never have an I.
Would it ever be like not positive and you just put like 9?
No, because you're adding, and both the numbers that you add are going to be positive because you're squaring them both. So it'll always be positive. You'll never have an I. So sine of theta is what over what?
15 over 17.
Y over r, so 15 over 17. Cosine of theta, x over r. So what would that be? Negative 8 over 17. And tangent of theta? 15 over negative 8. Always simplify your fractions if you can. Here, we can't. They're already simplified. So next we have our reciprocal function. So cosecant of theta, 17 over 15. Secant of theta, 17 over negative 8. And cotangent, negative 8 over 15. Just as a little reminder, kind of throwing it back to maybe like 6th grade math, negative 1/2 with the negative out front is the same thing as negative 1 over 2, which is the same thing as 1 over negative 2. So it doesn't matter where you put the negative. If you have one negative sign in front, they're all the same thing. So this one's a little bit different because it doesn't give us the picture, but does it matter? No, we still have x and we have y, and we know how to find r. So r is equal to the square root of x squared, so negative 4 squared plus y squared. What's negative 4 squared? 16. And 7 squared is 49. What's 16 plus 49? 65. Let's see if I can simplify 65.
No.
What are two factors of 65?
5 and 13.
5 and 13. And 13's prime, so can't simplify. We don't have any pairs. So let's find our trig functions. So sine of theta is what over what? Y over r. So 7 over square root 65. Can I leave this as my answer? No. What do I have to do? Rationalize. So multiply the top and the bottom by square root 65. So this is 7 square root 65 over 65. Notice that here it says exact values, so you leave your answer with the radical in it. Exact values never means decimals. Unless it was like 2.5, because that's exact. But if your decimal continues, then it's not exact, because you would have to round. All right, next we have to find cosine. What would our cosine be? negative 4 over square root 65, so we have to rationalize. So we get negative 4 square root 65 over 65. And then lastly we have tangent. What would our tangent be? Y over x, so 7 over negative 4. We can find our reciprocal functions just by flipping. So we have cosecant of theta.
When you flip, you go to like the original.
Yeah, I would flip the original here. Because if you flip the one that you rationalize, then the radical would be on the bottom and you'd have to rationalize it again. Which you'd get the same answer if you flipped that one too, but it would just be more work. So I would just flip the one before you rationalized it, because that way your radical is going to be on the top now. So square root 65 over 7. Next we have secant. What would secant theta be? Square root 65 over negative 4, so I'm flipping this one here. And then we have cotangent. What would our cotangent theta be? Negative 4 over 7. All right, B. What do I need to do first? Find R, which I think we've already done this one. So we have 3 squared plus negative 4 squared. What's R going to equal? 5. So we'll just do it again for fun. What is sine of theta? Y over R, so negative 4 over 5. Next, I have cosine of theta, x over r, so what would that be? 3 over 5. Then tangent of theta, negative 4 over 3. Then our reciprocal function, so cosecant theta, 5 over negative 4. Secant, can't really see that, secant would be 5 over 3. And then cotangent, so 3 over negative 4, or negative 3 over 4.